We're looking at the role of zeros when it comes to decimal points. For example, let me talk about this. See, how does zero can vary something and not vary something. Let me take up the number 23. I can write 23 as 023, right? Both are one and the same. But these two are not the same as 230. So this is the role of 0 when it comes to integer position, right? 0 in integers, in the world of integers, it definitely plays a role when we put it after or at the start, basically. More the number of zeros, bigger the number. But any number before the integer, right, it does not matter, right? It has no influence. It has no influence. While this has influence. Similarly, in decimal position, we are trying to figure out, does the zero play a role? When does it play a role? When it does not play a role is what we are trying to figure out. Okay, guys. Now we have bunch of numbers over here. I would want you guys to pause, have a look at it, and figure out if they are playing a role or not. Okay, the answer is not playing a role, not playing a role, not playing a role. It is playing a role, it is playing a role. Now can you observe why is it playing a role and why it is not playing a role? Both are important. So now, can you tell which is bigger and which is smaller from this table? The largest value is 0.2. Do you guys agree? While the smallest is, this is the largest. Let me write it off. While the smallest is what? 0.002. This is smallest. But of course, I want to discuss the reason. But why? I do have some more question. But why is it? Let me go back to our this representation, fraction representation. 0.2 is nothing but 2 2/10 of a number, while 0.002 is nothing but 0 into 1 by 10 plus 0 into or 0/100th plus 2 into 1 by 1000th. So clearly 2 by 10 is greater than 2 by 1000 parts, is it not? If I give you guys, say, some item after dividing in 10 parts, will you get more of it, or will you get more in this scenario wherein I divide the particular item, same item, into 1000 part and give it to you guys? Think of it as a birthday cake. I think you guys will be able to imagine this. If I divide it into 10 parts and give 2 pieces to you guys, or if I divide this into 1000 part and give 2 pieces to you guys, which will be a better scenario? This is a better scenario, right? You will get more pieces. So on the same line, if you think about it, 0.2 is much greater than 0.02. And that's why 0.2 is the largest and 0.02 is the smallest. Okay. Now, based on that, can you guys figure out the following set of question? So the question is, which of the following is the same value, which has the same value? 4.5, then 4.50, because adding 0 after a decimal point, oh, I didn't talk about that, will not make any difference. I didn't talk about that over here. I told that first 3 will not make a difference. I didn't explain why, so let me explain why over here with this example itself. So we will talk about, do I have space? Okay, let me do it here itself. Why 4.5 is same as 4.50 in terms of value, that is. See, 4.5 is nothing but 4 into 1 plus 5 by 10. While 4.50 is nothing but 4 into 1 plus 5 by 10 plus 0 by 100. So I can put any number of zeros, 0 by 100, 1000, whatever. Will it matter? Will it change the value? Answer is no. And so they are equal. But if I had a decimal, and then a 0, then these two will not be equal, even though they have the same set of decimals per se, technically, right? These two are not equal. Okay, let's look at it. 4 is there, 4 is here, 0, 5, 0, 5, and a 0, but it won't matter. So these two are equal. I don't have space, so I'm just marking it here itself. There's a 4 and there's a 4. There is 4 here also, because 0, 4 is same as 4, 5, 0 is same as 5. So basically, this is same as the first set, guys. Okay, so this, and this are the same. And we don't have any match for these two values. Okay, which is or are the biggest number of them all? Okay, 4.5, 4.50, and 4.50 or 0, 4.50. So this is the largest value. While the smallest will be 0.405 is what I think, yeah, 0.405. This is the smallest one because there is no integer value itself, so it's out of race. That would be by default the smallest. Okay, can you guys try similar one? I mean, we have a similar question. So 7.2 is same as, let's see, this will be same as 7.20. After the decimal, if you see any, you write a number, and after that you can put any number of zeros, it will not change. So that's why these two are same. And this is same as 0.7, oh sorry, 07.2. Reason being, before an integer, if I put a 0, it won't matter. So these three are same. Then we have 7.02. This is equal to 7.020. Then we have 0.72. It's not the same as this. And those are your two pair. Which is or are the biggest numbers of them all? So we have 7.2 is the biggest, guys. 7.2 is the biggest. So all the numbers which are related to 7.2, all those are the biggest. While the smallest will be 0.72 is the smallest. So what can we conclude? The conclusion is, remember this, when you see zeros at the very end of a decimal, after any other non-zero digits, they are often there to show precision, but they do not alter the numerical value. What is this precision? That would be something that we can discuss in the future, but not over here. It's basically more accurate. So that has to go with physics and science, scientific measurements, even mathematics also. But anyways, let me not go to that. So basically, considering the last non-zero digit, post that any number of zeros does not alter the numerical value. So I'll give an example. 4.2 is same as 4.20, which is same as 4.2000. So these set of zeros, it does not affect how or what the magnitude of this number is. They don't alter the value. Remember this. Okay, guys. So that's about your decimal and zero.